Alright, welcome back. Now we are coming to solve question 3 of the 2025 Wassce core mathematics question. So let's see question 3. An engineer builds a rainwater collection system in the shape of a hemispherical tank of radius 2 meters to irrigate a 500 meter square farm. Each square meter of the farm requires 50 liters of water. Determine with a mathematical statement if a full tank of water would be sufficient to irrigate the farm. Take pi equals 22 out of 7. So now let's see. An engineer builds a rainwater collection system in the shape of a hemispherical tank. So let's see hemisphere. That's hemisphere. So we can get a hemisphere, and the radius is just 2 meters. Okay. Now we can find for the volume of the hemisphere to be 2/3 pi r cubed, because the full volume of a sphere is 4/3 pi r cubed, and which is half of the volume of a sphere, so which is 2/3 pi r cubed. Now the volume here, which is 2/3 times pi, is giving us 22/7 times the radius is 2, so 2 exponent 3. Now the volume here is equal to, that's 2/3 times 22/7 times 2 exponent 3, and this is just 352/21 meter cube. So that's the volume of the hemisphere. That's the volume of the hemispherical tank. So which means that the amount of water in which this hemisphere can hold is 352/21 meter cube. So let's see, this is equal to, let's say, 16.7619 meter cube. Okay, now we continue. Now, an engineer builds a rainwater collection system in the shape of a hemispherical tank of radius 2 meters to irrigate a 500 meter square farm. So to irrigate 500 meter square farm. So the farm is 500 meters square, which is the area. Now, each square meter, which means 1 square meter, requires 50 liters of water. So 1 meter square will require what? 50 liters of water. So 500 meters squared, which is the area of the farm, will require how many liters of water? So we can say that if more, let's divide. If more, let's divide, which is x being equal to 500 meters squared all over 1 meter squared times 50 liters. So this will be equal to 500 over 1 times 50 liters, and we will get 25,000 liters. So which means the area, which is 500 meter squared farm, okay, meter squared farm, will require 25,000 liters of water to irrigate this farm. So we use 25 liters of water to irrigate the farm. Now let's see whether this volume of this hemisphere, the volume here, which is 16.7619 meter cube, can be used to irrigate this farm, which is 500 meters squared, because the volume of water will require to irrigate the farm is what? 25,000 liters. Now let's change the meter cube to liters. Now don't forget, 1,000 So now we can have 1 meter cube is equal to 1000 liters. So we can have 352 over 21 meter cube is equal to x liters. So if more, let's divide again. If more, let's divide. So we can get x is equal to, now let's change it to y. So y will be equal to, that's 352 over 21 times 1000 liters. So 352 over 21 times 1000 liters, and this is just 16761.90476 liters. 16761.90476 liters. So now this one is 16,761. 16,761. And now check the volume of water we require to irrigate the farm. The volume of water we require to irrigate the farm is 25,000 liters of water. That will require to irrigate this 500 meter square farm. Now, the volume or the amount of water this hemisphere can hold is 16,761. Now, since the volume or the amount of water this hemisphere can hold is less than the volume of water we require to irrigate the farm, which is 25,000. Since this is less than this, then it won't be sufficient, because they said determine with a mathematical statement if a full tank of water will be sufficient. Now a full tank, which means what? One tank of water will be sufficient to irrigate the farm. That's 500 meters squared. No, it won't be sufficient. We will need more tanks to be able to irrigate the farm, because this is 25,000, this is 16,761. So this 16,761.9046476 liters is less than 25,000 liters. Then it won't be sufficient to irrigate the farm. So we use the inequality less than, which means it won't be sufficient. We need more tanks to be able to irrigate the farm. Okay, so that's it. We proceed to question 4 in our solution.